Good afternoon, everybody, and welcome back to this final session of the Virtual Flow Forum. In this session, we're going to be very much talking about giving an update on the flow technology. We've got some really interesting technology. We've got Alastair MacKinnon from Pulsar talking about low power sewer network monitoring. We've got something new onto the MCERTs market, or potentially onto the MCERTs market, and I think they're looking for places to trial if you want to get in touch with them. We've got Keys from Augvald about measuring by microwave. Some of you may remember the microwave flow meters that we were talking about 3 years ago. This is next generation on, and we'll see some really interesting stuff there. And to finish this all off for the day, we've got Matt Westgate and Pete Devine from VEGA. And I know you're all very familiar with Matt. So at that, we'll start. I'll hand over to Alastair MacKinnon of Pulsar. So Alastair can talk to you about low power sewer network monitoring.
Thanks, Oliver, and thanks everybody. Just a quick introduction to myself, Alastair MacKinnon. I'm the Global Director of Sales for Pulsar Measurement. Been in the industry for, 30 years now, and 23 years with Pulsar, and I've seen a lot of developments with instruments over that time. I want to talk to you about low power sensors. If everybody was on the call this morning about the data, it was really interesting and harvesting that data, but you've really got to get decent data out of the sensors, and I'm going to talk about that, as well as the ability to create a low power environment to be connected up to loggers and these type of things. So we supply a lot of EDM MCERT-ed devices, and have been doing that for many years now, and have recently had a unit MCERT-ed for EDM, and we've worked with a lot of the water companies and installed quite a number of them over the past year, which has been very interesting. But I'm going to go a little bit off piste, because I'm going to talk about other sensors and low power sensors from there. So can I have the next slide, please? So quick agenda. Where are they used? We'll talk a little bit about that. The development of the contactless low power sensor, just a slide on that. We'll talk about the DBI and the microflow eye, our intelligent solutions for sewer network monitoring, and we'll bring in a few case studies and applications at the end with regard to river monitoring, irrigation, spill monitoring, but really concentrate on the sewer network monitoring, and tell you a little bit why velocity and level are two variables that are pretty critical in that kind of monitoring arena. Next slide, please. So where are they used? Low power sensors can be used in various different applications. As you can see there, I'm one for very much pictures rather than bullet points. I think they speak 1,000 words. So you'll see there a microflow eye, intelligent velocity sensor, and a DBI intelligent level sensor in a sewer, on a CSO discharge, on a tank farm out in Texas, and monitoring chemicals, connected up to a node, a remote telemetry node. You can probably just see that off the top of the tank. On irrigation channels and hanging off bridges, monitoring rivers in flood conditions, or monitoring flood conditions. So you can find sensors and low power sensors in various different aspects and applications. Next slide, please. And what do we need from a low power sensor? Well, we certainly we like to promote non-contacting. We do have contacting devices in the range, and you can see in that picture, I told you I'm going to show you lots of pictures today. You can see in that picture a velocity sensor that's contacting, and that's great. The only issue is when you start talking wastewater, ragging, and these type of things, you can cause yourself some problems and an extra maintenance visits to clean these. So non-contacting we feel is the best way to go. IP68, because these are going into, especially if we're talking about sewer networks, areas where they could be submerged. So IP68 is a good thing to have with your sensors. Compact. They're going into some small areas. They need to be installed and taken out of these environments. And if you think about a drain cover and the size of a drain and all these type of things, they've got to be pretty compact to withdraw them as well. Rugged as well. They get deployed, and people take no prisoners sometimes when these things are deployed, so they've got to be pretty rugged as well, and very much low power, and I'll concentrate a little bit on that on a few slides coming up. Next slide, please. So yeah, why there are some low power devices out there, and people ask me, well, why can't we use pressure transmitters? Well, we can, and they're good, and they're very good for clean water, but that's a picture I took many years ago, replacing a pressure transmitter in a wastewater lift station, pumping station, and that circle there is the pressure transmitter, probably 5 or 6 times bigger than it used to be, all full of rag and everything like that. So when you're in wastewater applications, non-contacting is the way to go. And as well, if you can reduce the power, then it's a win-win situation. Next slide, please. So how have we developed a low power? And I'll talk about the sensors and how low power they are now. But what we've done is we've reduced the boot time of our sensors. So if you look at a traditional ultrasonic radar sensor, to activate one of these things and power it up, it can take up to about 30 seconds. Then if you're going to turn that off and then you're going to turn it on again, it's very, very power hungry. So what we want to do is we want to turn the power the unit up, turn it on, and then turn it off again in the smallest amount of time, to get and also to also get a robust reading as well. And you can see here we developed our dBi range, and we can turn that on now. It can be activated, powered up, and can be turned off again within 4 seconds, which allows us to reduce the overall time of the unit having to read, and reduce the power considerably. And again, I'll come on to that. And we've recently developed a Modbus version, and we can actually wake that up now within a second and turn it back to sleep again and turn it off again. So that really does give us the ability to combine with loggers and to extend battery life in the sewer network system. Next slide, please. So again, looking at this, various loggers here and combination, we're pretty agnostic to any type of telemetry device, so we can connect up to a number of the devices, and people will probably see those and have seen them installed in lots of different sewer CSO applications. So next slide, please. And I won't concentrate and go over this range, but this is the range of our low power sensors, and they all use this very quick boot up time. The IMP on the right hand side was the very first iteration that we did, quickly surpassed by the dBi, because we found that even an IMP, when it went into sewer applications, if it got surcharged, there could possibly be a leakage issue if the cables hadn't been tightened up through the cable glands, these type of things. So dBi, fully potted IP68, and you can see there along the line, probably 1, 2, 3, 4, 5 down, the actual power per measurement. So you'll see there that the dBi, 14 microamp hours per measurement, fantastic. Microflow I is a little bit more power hungry, but still pretty good, 23 microamp hours on a 4-second wake up. You'll see that now with the Modbus, a digital device, you are talking that 1 second wake up interval. So it gives you 6 microamp hours per measurement. So it allows you to extend, and we were talking about 2-minute wake ups, 1-minute wake up this morning. It will help you with the battery life extension of a telemetry module as well. Next slide, please. So level is great, but when you are talking sewer network monitoring, irrigation monitoring, you want to really talk about flow as well as just level. So we did develop a microflow, what we call the microflow. It's a radar Doppler device. It was developed with Welsh Water many years ago, actually, when they came and sat down in our conference room and asked us to develop something that was compact, that would give them non-contacting, all the stuff that we mentioned before, because they'd looked on the marketplace and there were velocity Doppler radar devices out there, but they were quite large, very difficult to install into a small compact sewer network system. So next slide, please. And you'll see here a couple of pictures there of a microflow I installed. The size of it is pretty compact, size of the palm of your hand, and it's a loop-powered device, and it's actually patented loop-powered 4020 velocity, which we were pretty proud of doing that. It's certified EXIA, so for the sewer type applications it fits very nicely. It's 68 IP68, and again 10 to 28 volts DC, so you can use one of these remote loggers to power the unit without a problem. And the velocity range 0.2 to 6 meters per second. So we move on to applications, and I think these are always powerful to show where these have been working and what data we've got, and some information on that. And again, on their own altogether, what do we do with that data? So next slide, please. This is an application using the IMP, so we're going to talk about all the ones that you saw before, and this is flood alleviation, flood warning, and we've put hundreds of these in Japan. Japan is an interesting island. It's very tall in the middle, and it slopes off into the cities which are around the outside on the coast, and they get very big issues with regard to flooding, and we deployed a lot of IMPs with a logging company in Japan, and they can get now some very good data, early warning data on potential flood occurrences happening, and they can do mitigation with regard to that, opening gates, closing gates, depending on what they want to do, diverting the water flows. So yeah, that's a very interesting application there. Next slide, please. And here you'll see a microflow and a DBI in an irrigation application in Portugal. This is perfect for flow. You'll see the channel and the nice straight lengths. Lovely to get that in a sewer network, but that would be quite difficult. But on this application, to get a pretty good accurate flow measurement, utilizing the cross-sectional area of the trapezoidal channel there, and the laminar flow works very well, and that data is then transmitted into the logger. The logger does the velocity area calculation and then transmitted up to the server. I think if you click once, you'll just have a quick video there of that channel and that velocity moving forward. So next slide, please. This is the major thing I wanted to talk about. We've been deploying the microflow velocity sensor in lots of different parts of the world, in the UK, and the application at the bottom there is in Lima, in Peru. where we have a microflow eye and a DBI connected up to a logger. That's monitored down in that's installed into the sewer, and it's monitoring one of the main trunk sewers under the roads of Lima, and a number of those have been deployed to get information and to look at modelling, and also to look at potential blockages as well. So I think if you just take one more click, you'll actually see a video of that actually. Thank you. So yeah, you'll see there that the sewer running quite fast. The microflow eye and the DBI are mounted on the pole at the bottom with the logging device. That logging device polls those two, and the actual velocity and area or level is then sent up to the cloud, and in the cloud there the velocity area calculation is done to give the flow. But sometimes people will just want the separate velocity and the separate level as well, and I'll move on to the next slide, please, and I'll explain the reason for that. So you can just monitor level, and some people use AI now, artificial intelligence, to look at the potential blockages occurring in sewer networks. But there's nothing like having the real-time data as well from a sensor to clarify that. So a velocity sensor and a level sensor will give you that, and sometimes it's better to look at your velocity and your level, because if a velocity is slowing down and a level is increasing, you know potentially you've got a blockage occurring. If a velocity is increasing and a level is increasing, then we know that we've potentially, we more often than not got a storm. And again, we can check that with rain gauges and these type of things from a data point of view. Next slide, please. And again, a picture of a microflow eye and a DBI, and that is in Budapest. And the right-hand picture is a rat's eye view of the microflow. That's monitoring that old sewer running through Bratislava. Sorry, through Budapest. Next slide, please. And you'll see some data coming back now from these, and this clarifies what I was saying before, where you've got a velocity and you've got level. So we are seeing there a velocity signal that's increasing and a level signal that's increasing in 3 different points. So we're pretty comfortable there that that's just a storm surcharge rather than a potential blockage occurring. Next slide, please. And a bit closer to home, this is one of the UK water companies where they've been doing some modelling with our microflow, a different level device, going back to a logging, about 50 of these deployed in this water company, and they've just started to deploy another 200 to get real-time data once they've done the modelling as well. Next slide, please. And again, you can see some data from these devices as well, showing flow in green, so the velocity area calculated, the level in red, sorry, the velocity in red, and the blue, the CSO level on there as well. So some good correlation of that data. And you can see here where we did some microflow eye testing against a velocity sensor contacting, and again some really good correlation from that as well. Next slide, please. And again, the last slide I think I have here is some work we've done in the PUB in Singapore using a DBI in very small sewers, and the microflow monitoring the flow and looking at infiltration into that sewer network system. Next slide, please. And that's me finished. So many thanks for listening.
Thanks, Ali. There's some great case studies there, and very interesting to see. I think if we move quickly on, so we'll grab some time for questions at the end. Our next presenter is Alex Keys instead of Stuart Tyers. And Alex is from Augvald. Now, I came across Alex probably, about 6 months ago?
Sounds right.
9 months ago, maybe, and went to see them. And I remember the microwave pipe flow meter of about 3 or 4 years ago that didn't have much success. But this is, I think, to be fair, similar, but not as ambitious as it's doing level. But going to see it, going to see Alex and everyone at Augvald, I came across something very interesting. And from there, I'll let Alex take over.
Well, thanks, Stuart. Thanks, Oliver. I appreciate the introduction. As you say, I'm not Stuart Tyers. I'm his stand-in. I'm the Director of Sales and Marketing here at Angvald. And yeah, I'd like to very much thank Oliver in at least 2 ways. We probably wouldn't be here if it wasn't for him. So let me start off by introducing Angvald, because you wouldn't have heard of us. And this is a kind of coming out for Angvald. It's the first time we presented our products to a wider audience. So Angvald is a startup-sized company. We're funded by a serial entrepreneur, and we exist in a kind of network of his companies. Overall, they employ 5,000 people across a diverse range of industries. The team here at Angvald have worked in other companies, and we've spent the last 5 years solving one of the really difficult measurement problems in industry, which is the measurement of flare gas, so ultrasonic measurement of gas flow. Flare is particularly difficult. It's required a dedicated team, and over those past years, we've spent $10 million solving these really difficult challenges. As we sit here, we've solved the majority of those issues in that space. The resultant products are launched to the market and doing really well. So as we came to the end of that project, our owner started looking, what's the next challenge? And rather than keep going in the oil industry, for example, he's looked to move towards the world of environmental sensing, pollution protection. So what I have for you today is far from a finished version. It's probably a step on the journey. We think it's a really good step. We hope it will introduce you to Angvald and, of course, Angvald to the world of water. So here's what we're planning to offer as that first step. Nivå is a family of accurate level sensors for use in the water industry. So perhaps they seem a bit more evolution than revolution in many ways, but we're a small company, things moving really quickly. So today I'd like to present an overview on what these devices can do. Again, I'll give you some examples of real-world applications, places we've got data. And finally, I'll explain how you can get involved in the launch and rollout, why we're here. But the key points from this, plus or minus 2 millimeter accuracy on this microwave technology. We do plan an MCERTs application next year. And again, battery powered. And one of the key differences from other people is that we have this clamp-on variant as well. So these are the size of the two devices. Not quite fit in the middle of in the palm of your hand, unless you're a goalkeeper, but fairly in line with what's on the market. That accuracy we're very confident in now, and it's our aim to start an MCERTs application next year. Power is DC, loop powered or internal battery. Obviously, life depends on exactly what you're trying to do, how often you want measurements, but we think 5 years is totally achievable with the right settings. Now, the clamp-on device at the bottom, it's a touch larger, but it uses almost exactly the same internal hardware. One challenge we noticed where people had tried to develop these in the past was that they struggled at nearly empty and nearly full pipes. We're very happy now that we've solved that. The reliability at the top and bottom end of measurement is really solid. Now, both devices can produce readings from primary flow devices, your RIAs and so on. The clamp-on device also comes with a flow output, which is inferred. So you input pipe size and angle, and it knows the fill, so it will give you an estimate on flow. Not to an MCERTs degree of accuracy, but it's certainly helpful in some applications. I mentioned that this team have a long history using ultrasound for measurement, so it might have been natural for us to kind of take that experience and shoehorn that in here. But I think the right way to do the engineering is to take a look at what measurement principles and technology are out there and select the appropriate one for the application. And as we did that, we found that microwave has a number of significant advantages over other technologies. And there's a summary of them here, but essentially it's that accuracy, stability, and tolerance of external interference and dirt and things like that have really led us to being wedded to this. I'm not going to spend too much time explaining to this audience, many of whom are much, much more experienced than me, where you can use level sensors. But these are the kind of applications we had in mind as we developed and tested the Nivå sensor. So from the start, we've tried to consider not just how we can build a good level sensor, that's really, really important, but also how we can provide a little bit more information rather than just data. And much of what we're doing differently is the way in which the sensor unit itself can do some data interpretation. For example, the Nivå is able to analyze some trends and predict losses in pipe capacity. And then it can provide you an early warning of blockages and even predict maintenance issues before they arise. Clearly, we need to make a sensor where cost aligns with industry expectations, but by doing a little bit more, we hope we can increase in efficiencies and reduce costs. So something else we've had in mind again, since the very beginning is the need for scalability. This morning, we've seen a lot of very impressive companies using AI and similar technology to predict network effects based on a huge number of inputs. That's really impressive stuff. It's absolutely not what we do, but we definitely want to make sure that our sensor is ready to provide data to those really big advanced operators, people with data teams. I think they know better what they're doing than we do. So for these customers, we can provide a drop-in level measurement solution, which can provide that layer of data. At the other end of the market, we have an increasing number of micro operators. And a lot of the field trials we've done have been with those people. Farmers who want ideas of runoff, industrial estates who want to check drainage capacity usage. So in those cases, Nivå's been used as a point solution for these applications, easy to set up and no need for a DCS or SCADA system in those small applications, but you can still get actionable insights coming right from the meter, which non-specialists can make some use of. Let me show you through some examples of configurations. We put together a few accessories. There's a mounting frame in the center here. When I first saw this, I thought the R&D team had decided to put up some net curtains, but it's actually a really good system. So they are extending poles that will lock into an inspection chamber. The frame can be pre-mounted on those poles, so it's ready to go. And you don't need any special tools. You push it out, hand tight, make sure it's level, pointed at the water. It's extremely quick to go. We got one of our software engineers to fit one in a car park here. It's like 5 minutes work for a software engineer. So if our software guys can do that, I think it'll be really easy for experienced engineers. On the right is a T-piece insertion, useful for buried pipes. There's a grey coloured plug there, and then the sensor unit just goes in a quarter turn. And on the left, universal brackets. I think we're all familiar with how these work. The clamp-on version of Nivå needs to be pipe-specific, and that allows the curve on the bottom to match the curve of the pipe. Minimal special tools required for this. There's no acoustic paste, special cements, or anything like that. A few options for fitting, and I'll talk about commissioning in a minute, but the easiest is to take a couple of steel tie wraps, get them around the pipe, and pull it tight. Currently, we're supporting pipes from 100 to 500 mil, and it's plastic pipes only at the moment. We think we could go beyond that if there's a clear market need. So I mentioned we've got a few sensors already out there doing things, and a couple of these images feature in the videos of data I've got coming up. So from left to right, there's a balancing lake, there's a culvert, an inspection chamber, and finally a clamp-on installation, which I think is a rainwater pipe. So I've got some videos with some live data running. And in this first video, we're looking at one of our first ever deployments. And this is on an industrial estate that's really local to us. The landowner is looking at adding some new light industrial units and wanted some information on how much capacity he had for rainwater disposal. Now, annoyingly, there weren't any suitable inspection chambers which were easy to get to, but the pipe run did get across a ditch, so we used that as an opportunity to test the clamp-on sensor. So this is near St Neots in East Anglia, a pretty dry area, and it's fairly easy to identify days when it rained across the summer. This is estimated flow in terms of litres per hour, and like I said, that's estimated from angle, fill, and pipe size rather than being a proper level-based flow. That big spike that's just come in at the end of July, that's the tail end of Storm Evert, which dumped a pretty impressive amount of rain, and that flow rate corresponds to about 17 litres a second, pretty high. So all that data is coming from one of our prototypes through the pipe, not open channel. We're really happy with the quality of data we achieved with an early prototype. We're really happy with the stability of the system, how it performed in essentially sat in a farmer's field. So early data which shows that through pipe is absolutely possible. The second application here is a different industrial area owned by the same company, more offices and light industry. And this one had accessible inspection chambers, as it was a wastewater application rather than rainfall. So this was down chamber. It's gone back to the previous one. Excellent. Okay, let me try and run that. Okay. Sorry, it went back to the previous video. So yeah, the industrial estate owner in this case is looking at adding some. Sorry, in this particular case, there was no particular reason for deploying, just that we know them and they were keen to have one of the sensors, see what we could find. You can see your diurnal data on there, and you can see weekends. It's an industrial estate, so not much was happening. The accuracy is pretty good on this. We're about 1.5 meters from the water level, and we're getting stable readings moving sort of 1 or 2 millimeters. Really, from a basic level sensing perspective, very, very happy with that. We did send people out to make sure that was accurate. Another reason we sent people out to make sure it was accurate is that this waste pipe didn't drain to zero, ever. And we were concerned that might be a misreading. But every time we sent someone out, there was indeed 5 or 6 mil of water in there. So what we did early on a Saturday morning, when no one was in the industrial estate, is we turned off the water to the whole site, and then, lo and behold, that pipe emptied completely. So it was measuring correctly, and we expect that there's a leak somewhere, probably a toilet valve or something like that. Incoming metering to the site didn't provide any granular information, so that had never been picked up before, but we were happy again to be able to sort of solve a problem in a real world environment with an early stage device. So, like everything else these days, Nivå will come with its own app. So that will allow for setup and management of the device. It connects to the meter heads via Bluetooth. For your smaller operators, industrial estates and so on, there will be some data analytics included. We also plan for, if people want it, that those 1 or 2 meters they might need could send push notifications to the app for alarm exceedances and so on. Not something we expect the bigger scale operators to need. Something else we've had in mind since the beginning is cybersecurity. So the app uses encryption wherever possible, and it's been designed to ensure that members of the public, even if they can get physical access to the meter, shouldn't be able to adjust the configuration. Even if they can get hands on it and download the app, they shouldn't be able to make any configuration changes. We know how hard it is to secure every single site. So it's that app that you use to commission the meters, and it's another area where we'd like to add a little bit of value. The clamp-on is super easy to do because the pipe size input gives you both reference levels, full and empty. So you get that set up before you get out of your car. With any output options, alarms, all those kind of things can be done. When you get to the pipe, clean off the mud. It doesn't need to be shiny clean, but thick layer of gravelly mud is best removed. Get the meter flat level and then strap it down to the pipe, connect power and data, and you're away. Any post-commissioning validation you can do from Bluetooth range, and that should be it. The open channel meter needs very slightly more work. Again, you can pre-commission a lot of it. Essentially, the only other part, apart from fitting it and pointing it in the correct direction is setting your low and high levels using your bounce plate. The rest of the job is very similar, and hopefully with a pre-commissioned meter, good professionals should be able to install this in minutes. As I said, we managed to get our software engineers to do it. Today, every Nivå sensor comes with inbuilt 4-20 and Profibus. We're currently testing compatibility with common devices on the market, things like the Cello, to make sure that we can drop into applications. And the way that we built the sensor inside is very modular. The comms board is its own sort of entity. So it should be straightforward to offer other wired protocols if you need Modbus, and also things like narrowband IoT, wireless and cellular data. Although I took good note this morning of people saying, yeah, it's lovely, but we're running 15, 20-year-old SCADA systems. So it depends if there's a need for these things. It's something this team have experience with. And I mentioned before, we wanted to provide a bit more information to some operators and not just height measurement. So I've now got a little animation highlighting just one example of that. I certainly am not going to bore you taking you through all the things that we've got done and that we're working on. So this is my last video. There's a longer version both on our website and on the Congress site. And yeah, I don't have time to talk through all these bullet points. I definitely don't want to bore you. I mean, the system comes with inbuilt memory and things like this. But let's pick alarms and alerts. So firstly, obviously, alarm thresholds are configurable, not just in either absolute level or pipe capacity, but you can also configure how long the exceedance occurs before the system sends an alarm. Maybe 5 minutes or 8 hours is more significant for your application. And what we're seeing here is capacity levels being sort of bucketed up. There's 5 brackets here. Again, you could have 1, 2, 3, 4, 5 brackets depending on your application. And then the device is able, from the meter head, to produce these analytics, telling you how long each measurement point spent in that particular bracket. So again, depending on your application, that might be that pipe should mostly be empty, or it should be that it should standard run at 10 or 20% full. And you can configure the system to tell you, how long it's in each bracket. Sort of long-term data trends we can analyze as well, and the system can alert you to behavior outside the normal. Again, all this stuff is optional. If you're looking for an accurate level sensor and nothing more to feed into your SCADA system because you've got a great data team, absolutely fantastic. It can definitely do that. If you want a little bit more, we've got options for you. So finally, and the reason I'm here, how can you get involved? And nice stories, but what do we want? Well, here we've got a stock of version 1 prototypes, both kinds of sensor, clamp on and open channel. Not everything that I've told you about is fully implemented right now. Nivå's not CE marked, and like I say, we haven't started our MCERTs application, but we think as a basic level sensor, it's doing all the right things. So we're at the stage where we need more data from real-world applications and field trials to make sure we haven't made any mistakes, that we haven't done anything stupid, and to make sure the level sensing part is working in as many different places and applications as possible. So we're looking for operators, people who need to measure level and want to try one, and give us feedback. We'll come and help you get it working. We're happy to be put up on difficult applications against other devices. We don't need your money. What we need is your information, your input, and your feedback. I hope it's a good opportunity to be in early and to shape the future of the device and to some degree the company. But more broadly, we're keen to hear your pain points. Are there things that these sensors should be doing for you that they're not? This team likes difficult challenges, and we'd be really happy to talk to you about how we can solve those. So if this sounds like something you might be interested in, we're here. We've got a virtual booth at the Congress. That email comes straight through to me. There's a website with a phone number, which I'm happy to talk to anyone. So thanks for listening. And if anyone has any questions, I'm here with Stuart, our engineer, for the technical stuff. Thanks so much.
So thank you, Alex. Absolutely very interesting to see. Anyone who also wants to get in touch, they can always get in touch with me as well. So on to our last presenter for the day. And I think most of you know Matt Westgate of VEGA. no more introductions needed. So Matt, if you want to take over.
I believe it is a pre-recorded video that's coming up.
So hopefully that will be coming up any second. So whilst the AV, yeah, okay. There we go.
In the WWEM Virtual Flow Forum. We'd like to thank Oliver for giving us this opportunity to discuss the application of MCERTs compact level sensors for flow and event duration monitoring. My name is Peter Devine. I'm Technical Manager at VEGA Controls in the UK, and my colleague Matt Westgate is our Business Development Manager for Water and Wastewater. Okay, we're mindful that there is a great depth of knowledge within the Virtual Flow Forum in the field of open channel flow. However, we would like to start with some basics for those who are not so well acquainted with level flow. The sensors we'll be discussing will fall under the Environment Agency MCERTs performance standard. This is part 3, which is performance standards and test procedures for water flow meters. You can see a cover of the Environment Agency document there. We're also mindful that there is a draft, a part 5 for performance standards and test procedures for event duration monitoring. And this draft was released just on the 5th of October this year. If we look at the flow applications under part 3, the main applications are intermittent and continuous effluent discharge monitoring, mostly in open channels, and also instantaneous flow for flow rate for such things as flow to full treatment. Clearly, this is a well-established area of measurement. If we look at the latest draft for the event duration monitoring, the EDMs submitted for certification under this standard can be categorized in the following types. So there is a type A, and this incorporates level sensors that provide continuous level measurement beyond the overflow level. Type B is an EDM which basically has a switched output that indicates that the water has reached the overflow level. And there is also a hybrid of these two. So basically a primary device that indicates an overflow and triggers a non-contact sensor to take continuous level measurement. Essentially, we're talking about devices in the area of type A and the hybrid. So let's take a look at the existing range of MCERTs level-based open channel flow monitoring. Again, you can start with a generic controller with a housing. This comes generally with a display, and this could be a simple flow rate and totalization, or it could be slightly more sophisticated. It'll give things such as status indication, it could be color or monochrome, and maybe there would be a bar graph to show flow rates. Controller carries out the flow calculations, and there will be something like a keyboard to interrogate that, to set the instrument up. In general terms, this will have things such as relays for totalization, and it also comes with a mains power supply. A non-contact sensor, such an ultrasonic transducer, can be connected to that. But the ultrasonics may, in fact, need an additional temperature sensor to improve the accuracy class, and maybe the addition of a sunshade or two. However, there are smart level transmitters, including radars, that can connect to controllers such as this. However, the non-contact radar will not need temperature compensation for the runtime compensation. So the non-contact radar and the controllers themselves will have a comms output. So there could be data logging in various different formats. But if we look at it, most of the current level-based flows certificates on the CSA website of this basic configuration. So the flow linearization is carried out inside the controller. We're talking about compact devices. So let's define what we mean by a compact MCERTs level-based flow meter. If you look at this photograph, we can see what looks like a very basic level transducer that needs to be connected to a controller to provide the flow calculations. In fact, this is a smart non-contact radar level transmitter with the capability of providing 32-point flow rate linearization computation internally inside that sensor. Or simple, accurate level measurement, but compact. It does not require a controller. In addition to the linearization for flow, it can provide heart diagnostics, including parameters such as measurement reliability. So these compact sensors can be configured either for level or for flow using a simple but secure Bluetooth connection from a PC or a phone or via tablet. Let's see what this app looks like. These are screenshots taken from the VEGA Tools app. We're connected to one of the MCERTs certified compact radar level sensors. And we've given it a tag number EDM flow to reflect the flexibility of the compact sensor, as we shall see. Okay, the first thing on the application-based setup is to set up the instrument, the radar, to do a particular task. So by selecting an application, in this case, flow measurement in flumes and weirs, the app will automatically configure the instrument to do the correct function. So the app also gives you graphical representation of the application as you move through the setup. So we can see that we're monitoring a flow in this case. The adjustment of the sensor is based on distance from the sensor reference plane or the datum, which is the face of the sensor. So we set up our minimum and maximum distances. We can then go into a linearization assistant or a setup wizard, if you like, where we can step through the setup for a particular flow application. So we select flow measurements, and then it gives us a number of options, including the ISO standards, for flumes, for thin plate weirs, and also for broad crested weirs. So in this case, we can select a thin plate rectangular weir, and we can confirm our min-max adjustment. And then we can continue to set up the dimensions for this particular primary flow device. So you can see we have the approach width, the plate width, and the plate height. Next, we can select the engineering units we want, the flow units. So in this case, we've selected cubic meters per second. And then we continue through the wizard and it gives us a summary. And that essentially is the setup completed. When we come out of the setup, we can see on the display here that we have filling height and we have scaled flow rate displayed with the VEGA Tools app. So a nice flexibility and good visualization. If we look at a radar sensor with a local display, it also has bar graph indication. You can see the tag number, the EDM flow 01 tag number, and we can see our engineering units in cubic meters per second. If we don't have a local display, we have the possibility of using the Tools app. And here we can see on a phone that we have the filling height in millimeters and the flow rate in cubic meters per second. The Bluetooth connection is secured with a 6-digit PIN for pairing. It uses a challenge response procedure with a cryptographic hash algorithm and random number generation. On top of that, there's an additional locking PIN code that is used to prevent unauthorized or unintentional changes to the setup. These compact sensors have further flexibility when it comes to installation in hazardous areas. The instruments with housings have ATEX certification, intrinsically safe, and the compact sensors have both intrinsically safe but also EXM encapsulated certification. So basically, it doesn't need a barrier. The flow rate and level can come directly from the sensor, so it can be configured for either a flow application or for an overfill application in a very clear setup method. And that leads us to the possibility of connecting these devices to either a battery-powered data logger, a remote telemetry unit or SCADA system, or as we discussed right at the very beginning, it can be connected to a controller with a totalization function. So a lot of flexibility in terms of how these devices can be applied. So what's new? Matt is going to summarize how these compact sensors can be applied in open channel flow and event duration monitoring. Matt.
Thank you very much, Peter. Thank you everyone for joining us today. As Peter said, I'm going to talk about 5 features that these systems offer that we believe currently aren't available in the market. And these give some benefits and add value from all aspects of the system's life. So that's from installation, from even before that, from the engineering, the design, to the installation, to the maintenance and the ongoing operation of the system. So first one I want to talk about is the Class 1 performance in all conditions. Many level and flow applications are subjected to environmental conditions which can change quickly and be quite unpredictable, typically during sort of storm events when accurate and actionable data is at its most valuable. So by having a system installed that is very resilient to these different harsh measuring conditions, it allows you to make decisive actions. It gives much cleaner level and flow data. So it's much better data to be able to analyze for planning and for modeling. And as Peter was talking about before, we're really reliable and accurate without the need of protecting it from direct or indirect sunlight. We don't have any issues with things like condensation and build up around the sensor. So much less maintenance and a really stable signal. Simpler installations, as I was saying before, and helping people to save time and money. Second point to talk about is it's Class 1 certified over a 5-meter measuring range. So a lot of level and flow instruments need to adapt to an ever increasing variety of measurement situations, and some have accessibility issues. Current non-contact sensors, those systems require the measuring head to be quite close to the liquid surface to allow them to maintain the certified accuracy. And this can create some safety issues. So by having a 5-meter measuring range, this enables you to mount the sensor in an easy to reach location, so much better for safety. That coupled with a very narrow focusing, using 80 gigahertz as our frequency, we get a very focused beam. So we don't, by mounting it further up, we're not susceptible to influence of any internal structures and that sort of thing. And that's really important. So overall, we've got a lot more flexibility in where we mount the sensor when we're engineering the solution. It gives us a quicker and an easier installation. So that's a faster and a safer deployment of sensors. Third point I wanted to talk about, and this is touching on and sort of reiterating what Peter was saying, it's a standalone Class 1 transmitter. This really comes into its own in some of the event duration monitoring. sort of UMON3 applications and the requirement for monitoring the lowest spill point to storm tanks. Quite often the location that you need to measure is in a remote location. There's no power. And so it makes it quite difficult to put power in, or it can be quite tricky when you're looking at power consumption of a battery powered system. So these are loop powered transmitters, so we don't have to have a box on the wall to give that MCERTs accurate measurement. So this allows you to put battery powered systems in that really do optimize that power consumption, ideal, as we said, for remote telemetry and data logging. You still have that 32-point flow calculation that you can take direct from the sensor's head. And by having it as a standalone sensor, it means that you can minimize the amount of technology and infrastructure that you're having to install. If you don't need the functionality of a box on the wall, you now have the option of putting a sensor in that doesn't actually need it. The fourth point I wanted to touch on as well, again, something that Peter was obviously talking about, is Bluetooth. Bluetooth communication comes with all our radars and controllers as standard. And as what Peter was saying, this provides a really quick, simple and safe and secure way of connecting to the instruments. When we've looked at some of the draft EDM standards previously, there's been talk of being able to, any Environment Agency officer or MCERTs inspector, being able to look at a sensor's display and see its current status with relation to the switch point or the spill point. That doesn't have to be through a physical display. It could be through an app-based display, like what we've got here showing on the screen. Bluetooth really does give a lot of flexibility in how you can set the sensor up from a safe location, and it's just extremely convenient, making sure you've set the instrument up right the first time round. And the final fifth point that I just wanted to kind of summarize on is that when you do need a controller for data logging, for totalizers, for a local display, or for retransmitting the signal into telemetry, we have got the option of a single channel controller or a double channeled controller. So here we've got a couple of different applications. On the left hand side is your spill point to the storm tanks, so your EDM, your UMON3. There we've selected a radar that actually has a display in the head, coupled up with a radar on the right hand side on an open channel flow application. We've mixed and matched here, so we've gone with a fully potted cable version, and those two sensors are feeding back to one controller. So that's allowing you to completely maximize the functionality of the controller, maximize the space in the panel. And you've got multiple totalizers. You've got an 8 gig SD card that comes with that. So if you're monitoring data at 1 minute intervals, that's 185 days worth of data. So that's nearly 6 months worth of data at 1 minute intervals. And so it really does offer you a huge amount of flexibility when we're applying sensors in MCERTs applications as they continue to evolve from not just open channel, but to EDM as well. So that kind of summarizes our session. We hope that you found it informative, and we welcome any questions.
So thank you. We do have one or two questions that have come through the chat, and just for the AV guys, I'm getting the bounce again. The main question was for Alastair. What's the battery life of these devices, and how often do crews need to replace the batteries?
Very good question. We try to reduce the power as much as we can down, as I said, to the Modbus, which is 6 microamp hours per measurement. We've done a calculation with a standard logger, say Metasphere, Cello, even a logger that's in our group now called the Ranger. And if we're just talking the measurement, the physical measurement, they've obviously got to consider getting the data up to the cloud and all these type of things, which again is going to suck power. But just taking the physical measurement, you're talking up to 10 years, and that's at 2 minute intervals. just with
That's
that
impressive.
dBIM and 1 second wake ups.
That
But
is impressive.
there's obviously other influences, and I would suggest that probably you need to talk to the logging companies as well with regard to that.
So, to be honest, we've got two very experienced companies in the level market, in Pulsar and VEGA. What advice would you give to Augvald right now? You've seen what they've got. You both know the water market very, very well, and you've both got excellent devices. What advice would you give?
Stick at it. It's a long old road. I see Matt's laughing there, and yeah, it really is. I mean, VEGA have just come into the wastewater market in a way, and they've got some really good solutions and these type of things. It takes. I remember starting with Pulsar measurement 23 years ago. I was the first sales guy, and all I can say is stick at it. It takes a bit of time. If you've got a good product, you'll get there, and you're innovative. You will get there. But the water industry, and I do apologise to anybody that's in the water industry when I say they're a little bit like sheep. When one goes, then a lot of them start to go as well. But as long as you've got a decent product from that side of it. So excuse me calling you sheep anyway as well. So I don't know, Matt, you can, I'm sure you can attest to that as well.
Yeah, I completely agree with you, Alastair, in terms of sticking it. You know, there's a lot of good equipment out there from a lot of different companies. I think that there's application areas where people can excel in different areas, different ways of applying kit. But there are some people in the water industry that are very keen to look at whether things can be done slightly differently, embracing smart instrumentation, moving forward away from sort of maybe traditional ways of doing things and sort of seeing what is the outcome if we do something slightly different. Is it quicker? Is it more accurate? Is it more efficient? You know, is it giving more reliable, actionable data? Obviously, people have been talking about a lot of measurement points today. But yeah, I completely agree with Alastair. Stick at it and get kit out there exactly as you kind of asked on this platform. And I'm sure if the kit's up to sort of the performance, as you say, it'll gain traction.
Just to give you a little bit of an idea from a gestation period, we developed the Microflow I in conjunction with Welsh Water, and I'm going back now 9 years or so, coming up to double figures soon, and we're only deploying it in numbers now, really, within the UK water market. And it does take time. People have to be sort of secure in the knowledge that this will give them the right data, and it's right for them. But yeah, stick at it.
So we've got a question for you, Matt, from Tom Garwood. Your presentation mentioned the installing in remote locations needed the battery power. How do you manage data transmission in these remote areas where comm signals are poor?
Good question. As we sort of talk a lot of time, we're a specialist in the level measurement side of things, in the making of and applying of those sensors. We work in collaboration with specialists in telemetry. So some of the projects that we've been doing that are being scaled up at the moment are working in partnership with companies that specialise in battery-powered telemetry systems. They're working on the latest comms, remote aerials for sort of increasing the signal quality where it is low. Some parts of over on the East Coast, even though it's a bit flat, seem to be struggling with some signals and things like that. So to answer the question, we work in partnership with specialist telemetry companies that have different ways of getting over that.
And to be honest, the whole comms issue is challenging in certain areas of the country. I will note that there is a SWIG workshop coming up in, I think, November, December on comms. Let me double check that for you. But that is coming up, and it's around about that. And I think the whole comms issue, especially around communications protocols, is a challenge at the minute. So that's 20th of October. There's a comms and protocols for sensors being chaired by Alex Gray of Thames Water. So yeah, do go and have a look at that if you're interested in comms. Battery life, I think, has come on a lot over the past few years. I'm seeing battery mags which would struggle to last 2 or 3 years. Now they're lasting over 10. So I must admit, everyone talks about big bang innovation, and we're seeing big bang innovation. I think we've seen a huge amount of innovation in flow monitoring in the past 10 years. Radars were never really an issue. They were never really a thought because they were far too expensive. And there's a lot of really, really amazing work that's been done on radars to bring those down into companies' price ranges. And what's next? A water company asked me, what do we do for part-filled pipes? Well, we've had a presentation today for level in part-filled pipes, not quite flow. We've had that talk. We had a product 4 or 5 years ago that promised level-based flow in part-filled pipes, but hasn't quite got there. Maybe, as Alastair says, it's another 4 years till that 9-year mark. Maybe I'm not 100% sure, but yeah, there's some interesting applications, and flow management is only going to get more and more and more important. One of the things we've got is, today was the Flow Forum, tomorrow is the Pollution Forum, and it's all about monitoring for pollution tomorrow. The questions we had today, why monitor, how we manage, are mimicked tomorrow, and a lot of that's going to be monitoring for pollution. A lot of the FFT issues is going to tell us how the network's performing. So the flow area of the industry is going to be even more essential in the future. What's everyone's thoughts? What do you think? Are we right in flow management? Are we?
I would tend to agree, Oliver. I think flow management, certainly the certification of flow management and MCERTs is a big thing. We were dragged kicking and screaming into the MCERTs arena. We embrace it now. If you're going to manage flow, you've got to have accurate data, and it's right that people should be challenged on this as well.
Yeah, I'd just add to that. When we started talking to the water industry about 7-8 years ago with our first water radar that was a lot bigger and more expensive than it is now, a lot of people said to us, does it have MCERTs? And we said, well, we're using it for level. And we didn't understand what MCERTs meant and where it was actually required. And we went off and obviously did a lot of learning, and sort of a lot of those applications we were talking to people about weren't MCERTs applications anyway. What that's kind of done full circle now, where we've got MCERTs for this range of products, and people are saying, well, it's that stamp of quality and accuracy that then it's outside verified third party. That then gives it additional credibility in where it can be used in other parts of the business. I know Darren has sort of put a question about the sort of the draft standards, and we keep referring to it. Well, every draft that we've seen that relates to the EDM is about the accuracy class from a non-contact sensor, which this product is more than capable of. obviously companies are having to make decisions as to what they put in, down to timescales that they've got, and trying to future-proof themselves. And so that's why we kind of keep talking about it, because as far as we're concerned, and we're aware, we're offering something that will tick the boxes.
It's important. I mean, a lot of people don't realise that the investment cycles of the water industry, and Alastair said 9 years. There's a reason for that. It takes time. What you're going to install, you're going to install in bulk. A UIMF2 was 1,000 sites. UMON3 has got to be around about 3,000 sites. So that's a big investment, and I think we've got to remember that the cost of the actual instrument is a fraction of what it costs to install it as well. So these are big investments that the water companies are making, and so they naturally they want that stamp of quality. Of course they do. Now, is there any more questions from anyone? I've got something. James Luckett saying, have you used satellite comms with your kit?
Not that I'm aware of yet, but our instruments aren't fussy what they get, what they connect to. So we'd be more than happy to. We'd be more than happy to look at that.
We've connected up to loggers, and I think Matt's right with what he says. You know, we're kind of agnostic. We're experts in level and flow and velocity and all these type of things. We leave it up to others to get the data out of the ground up into the cloud. And we've actually connected to a number of devices where it's been very remote, in Australia, in Texas, in the States, where they have used satellite, and it's worked very well. But that is, I guess maybe it's a good session to have, Oliver, for logging companies, and to come on here and talk about their comms and how robustly they get the data up.
Yeah, as I said, the next comms session is the SWIG webinar in October, towards the end of the month, and I know that it's going to be brought up in there because ground control, which is Matt Westgate, is leading in that. I know they work with Immersat and the likes, and realistically on the comms issue, I think it's going to be a combination. Yes, it's going to be satellite. Yes, it's going to be radio. Yes, it's going to be GSM. Yes, it's going to be probably 5G. We've got a point made here by Andrew Chappell. MCERTs for EDM plan to be a requirement from 2025. So that's the UMON3. I think a lot of the current flow, I'm going to correct me if I'm wrong, Andrew, and do put something in the chat, but probably a lot of the certification that are already certified for flow, level-based flow, hopefully will be automatically grandparented over to UMON3. And I'm sure a lot of the manufacturers will be looking at the product standard, and I know a lot of the water companies will be as well, now that we've seen a version of that. And we can take it from there. And yeah, there isn't a UMON3 standard at the minute, but hopefully I think most of the level-based flow that's already certified for level-based flow will be automatically grandparented across. Hopefully that will be the way it works, but I don't think any of us know yet.
What we're seeing is a lot of people future-proofing, Oliver, and I guess Matt will say the same thing, and they're asking for an MCERT-ed EDM. And we're supplying to a number of the water companies now a device that we saw the draft, and we developed something as well as Vega did. You know, you pays your money, he takes your chance. So
I mean, to be honest, when I see a lot of the devices on there, I don't see why it wouldn't be, to be honest. There's some absolutely great devices out there. And I mean, I started with Angvald in 2012, and I think it's the whole industry's jumped on leaps and bounds, really.
Agreed.
Which is great. Mark Swain, improvements in internal data storage, the Pulsar SD logging have been a big help in some of our more remote and troublesome sites in respects of comms. Yeah, absolutely. Comms has always been an issue, it always will be, to a certain extent.
Yeah, it's something that we put onto the Ultra 4 was oodles of logging. And again, I know Matt mentioned it as well. So if you do lose data, you don't lose it completely. You might have to send somebody out in a van to gather it, but it's there.
Yeah.
And you don't have those gaps, and that has helped a number of the water companies gather that data.
I must admit, one of the really nice innovations I saw was dynamic logging as well. So when an event is triggered, probably by the relay, that dynamic logging happens. So it moves from 15-minute data to 1-minute data or whatever. And I think that's one of the really lovely innovations I saw, because it helps the storm events.
Yeah.
More and more with UMON 3 and UMON 4, we're going to have to record those storm events. And yes, it may well help the SAMs of this world who want as much data as they can get. As you say, it could be pick that up from the device afterwards, and with the Bluetooth, with the everything else that's been developed now, it's a wonderful way of doing it. So unless there are any more comments or anyone wants any other discussions, I'll say thank you very much to our speakers for this last session. Thank you very much for our speakers for the day. I think it's been a fascinating session, and I hope you've enjoyed us. If you're interested in wastewater-based epidemiology, the next on this channel will be exactly that. It's going to be a fireside chat with some of the global experts on wastewater-based epidemiology, and literally asking the question of, well, we've had it during the pandemic. Do we need it moving forwards? Open question. I don't know the answer. I'm not an epidemiologist, but if you're interested in that, do stay on. Tomorrow we have the pollution forum, exactly the same format as today, different set of speakers, of course. And we're also talking about net zero tomorrow afternoon in the 3 o'clock roundtable time slot. So at that, thank you all very much for coming. Thank you to all of our speakers, and enjoy the rest of WEM. Do visit everyone's stands, virtual stands. I'm sure they'll talk to you for hours about what they have to offer. Thank you very much, everyone.